So here I'm going to look at a past paper question from the Leaving Cert. It's on coordinate geometry. The circle came up in 2020. It's paper 2, question 2. So here we have an equation of a circle C. You're asked to find the distance between B and T. A few things to note. You're told that the line L, which is that line that B and T are on, is a tangent to the circle. So if it's a tangent to the circle, then what it does is it makes a line which is perpendicular to the center, okay, and that's the radius. So it makes a right angle triangle. As with a lot of the problems in geometry, if you can make a right angle triangle, then you're going to find it really useful to either work out some of the angles or work out some of the sides in the triangle. Okay, so we're going to make use of the fact that we've got a right angle triangle there to work out the distance between B and T, so that's that pink line. So an important thing to bring in first is the general equation of a circle and what that means. So I'm just going to bring in that formula from the tables. So you can see the equation above there, x squared plus y squared plus 2gx plus 2fy plus c. That can represent any circle. And we can get some really useful information from that. The coefficient of x is this number called 2g. And something that we know is that the center of the circle is represented by the numbers minus g and minus f. So if you know the coefficient of x in a circle, then you can work out the x value of the center. If you know the coefficient of y in the circle equation, then you can work out the value of y of the center. And we can also use those numbers and the constant in the circle to work out the radius. So we're going to use that now. So if the center is minus g minus f, then the center of any circle is going to be minus half of the coefficient of x in the equation, and the y value will be minus half the coefficient of y. So for this circle, the center is represented by A, which is going to be minus a half of the coefficient of x. So it's going to be minus a half of minus 4. So minus a half times minus 4 gives you the number 2. And minus a half of the number 2, which is the coefficient of y, is minus 1. So therefore I know that the center, which is the point A, is the point 2 minus 1. Now, let's work out the radius. The radius is going to be, just straight from the tables, the square root of g squared plus f squared. Well, g here is minus 2, so it's minus 2 squared, plus f squared, which is 1 squared, minus c, so minus 4, which is plus 4. So that is the square root of 4 plus 1 plus 4, so it's the square root of 9, which is the number 3. So the radius there is 3. So I know one side of the triangle, that radius is 3. Now we need to try and work out the distance between B and A, and if I can do that, I can use Pythagoras to work out the distance BT, which I'm asked in the question. So I'm just going to use the distance formula, which is straight from the tables, to work out the distance from B to A. So I've just put in that formula there. The distance formula is the difference between the x values squared plus the difference between the y values squared, and it's the square root of the sum of those. So if I'm looking for the distance between B and A, that's the modulus there, it's going to be the square root of 5 minus 2 squared, because they're the x values, plus 8 minus minus 1 squared, which is 8 plus 1 squared, and that gives me a result of the square root of 3 squared, which is 9, plus 9 squared, which is 81. So 9 and 81 is 90. It's the square root of 90. If you want to simplify that down, that's just going to be root 9 by root 10, which is 3 root 10. We don't need to do that here. We're just going to plug it into Pythagoras because we just need to work out BT. So we're just going to use Pythagoras now to work out the distance from BT. We know that in Pythagoras, BA squared, which is the hypotenuse, is equal to the sum of the other two squares. So BT squared plus TA squared, which is just the radius. I'm looking for bt, so I just rearrange. So bt equals the square root of ba squared minus ta squared. So that is going to be root 90 squared is just 90 minus ta, which is the radius, which is 3 squared, which is minus 9. So that's going to be root 81, which is 9. So now we're going to quickly have a look at the next question on that paper, the next part of the question, and it still relies on coordinate geometry of the circle. We have two circles, C1 and C2, and they have their centers on the x-axis. Each circle has a radius of 5 units. The point 14 lies on each circle. Find the equation of C1 and the equation of C2. So this is a common enough question. When you're asked to try and find the equation of circles, then the only difference between the equation of the circles is the number that G represents, the number that F represents, and the number that C represents. They're the only differences from our circles. So what we're going to be doing is we're going to be trying to plug in numbers and solve for G, F, and C. So our general equation again is here. That's x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So we're going to try and use some of the information that we have to work out something from the circles. Typically in these you end up using simultaneous equations to solve for the unknowns. First information that so the first thing is that they've got their centers on the x-axis. The centers on the x-axis, then the y-coordinate of that must be 0. So the number f has to be 0 in our equation here. So let's work out our first equation. Is going to be equal to minus g minus f, but we know that the f coordinate is 0. The radius is equal to 5. So if the radius is equal to the square root of g squared plus f squared minus c, then the radius squared is equal to g squared plus f squared minus c. So the radius squared is going to be 5 squared, which is 25, is equal to g squared. And we know that f is 0, so minus c. I've got one equation in g and c. I don't need to find f, I know it's 0. I just need to get another equation in g and c to work out what g and c are. Because if you've got one unknown, you need one equation. If you've got two unknowns, you need two equations to find them. So what we're going to do is use the other piece of information that we have. That lies on each circle. So if this is our equation of the circle here, then I can plug in the number 1 for x and the number 4 for y, okay, to get an equation in g and c. So let's do that now. So for the second equation, we're going to have 1 squared plus 4 squared plus 2g times 1. We know that f is 0, so we can ignore that. We can just write 2 times 0 times 4 plus c equals 0. So rearranging that, we're left with 17 plus 2g plus c equals 0. So now this is a second equation in g and c. So I'm just asked to solve for g and c now. I've got two equations. I'm going to use the simultaneous method using substitution, like you can see on the website. So I'm going to rearrange that equation for c. That means bring c over and bring 25 over. So c is equal to g squared minus 25. And what I'm going to do is I'm going to substitute that value of c in here. So we're left with 17 plus 2 times g plus c, when we're going to put in our new value of c, which is g squared minus 25, equals 0. Just rearranging, I've got g squared plus 2g minus 8 equals 0. And if I solve for g there, g plus 4 g minus 2 equals 0. g equals minus 4 or g equals to 2. And they're going to lead to my two circles. So now what I can do is I can substitute that value of g into this equation for both of them. So c then is equal to minus 4 squared minus 25. So minus 4 squared is 16, minus 25 is minus 9. Or c, if I plug in this number 2, is equal to 2 squared minus 25, and that gives me a result of minus 21. So the equations of both circles will be, so circle 1 is going to be, let's change my font there for this, x squared plus y squared plus 2g times x. Well, g is minus 4, so that's going to be minus 8x. We know that the f value is 0 because they're on the x-axis. Plus c, so that's minus 9 equals 0. And the second equation is going to be x squared plus y squared. All I'm doing is plugging this into that equation. There. Now I'm going to have plus 2gx. Well, here g was 2, so that's plus 4x plus 2fy, but I know that f is 0, so that's going to go, plus c, and c is minus 21. So that gives me the two equations of the circles. So that's the equation. Just to show you another method, in the table you'll see that another way of writing the equation of the circle is x minus h to be squared plus y minus k to be squared equals r squared. So we use this equation when you know the radius and you know h and k, where h and k is the center. So now using this information here, g is minus 4 or g is 2. That means the center is equal to 4, 0, or center is equal to minus 2, 0. Because, remember what we said, the center could either be written minus g minus f. If g was minus 4, then minus g is plus 4. So circle 1 would then be equal to x minus 4 squared plus y minus 0 squared, because we know that the other value of the center is 0. That's a k. That is just a k. So that's plus y squared equals to our radius squared, which is 25. Or the other circle will be x plus 2 squared. Essentially, this version is equal to this. This version is equal to this, just with expanded brackets. Both are correct. Both just use the formula for the equation of a circle represented slightly differently. Either version is correct. The main thing there is that if you know g and f, then you can work out the center. And you can either then use this equation up the top in green, or this equation here in yellow to work it out.